Hello everyone, welcome to our YouTube learning channel Accurate ASME ISO. Thank you for your great feedback on our previous video about composite tolerancing. In this video, we will dive into two single segment positional tolerancing. If you search online about this, you will likely find that the most common explanation is like that the two frames are completely independent of each other and should be evaluated separately. However, users often struggle to understand the exact and the real difference between the composite and multiple segment feature control frames. There is more to this topic than just the simple explanations. This will help you visualize the real concept of multiple single segment tolerance frames. So, please do not forget to subscribe and share the video with your friends. Now, let us get started. Let us quickly find the key differences between composite and two single segment tolerance frames. In a composite positional tolerancing frame, there are two segments, but only one position tolerance symbol is used for both of them as a common. In a two single segment frame, each single segment has its own separate positional tolerance symbol. In composite positional tolerance frame, the upper and lower segments can have the same datum feature references. This means that in the lower segment, one, two, or even all of three datums can be repeated as shown here. In the upper segment, the datums D, E, F, and also at the segment below D, E, F are repeated. However, in two single segment tolerance frames, it doesn't happen. All three datums cannot be repeated exactly. For example, as shown here, D, E, F are the three datums in above segment, while in below the exact all D, E, F cannot be repeated. If D, E are repeated, then F should not be. Although all three datums cannot be repeated exactly in the lower segment of two single segment tolerance frames, a new datum which is different from the three can be added if required. Composite positional tolerancing concept in GD&T used to control the location of a pattern. The pattern consists of the feature of sizes. There are two segments as we know. The upper segment is controlling the location of the pattern, while the lower segment controls the interrelationship between the features. That means within the pattern there are several features and those features are constrained in rotation and translation. In the example of composite positional tolerance zone frame, a part, which is a pattern of two holes, can be located within diametric tolerance zone of 0.1 relative to datums A, B and C as given in upper segment of the frame. A part or pattern of holes can be translated and rotated within 0.1. The animation in figure 1 shows that how part can be translated linearly in x and y direction. In figure 2, it is shown how a part or pattern of holes can be rotated. In the lower segment of the frame, only one single datum A is repeated. It constrains the rotation of holes relative to the datum A within 0.05. It means that perpendicularity of each hole are controlled within 0.05 with respect to datum A. Now, let us repeat primary and secondary datum features of upper segment into the lower segment of the composite tolerance zone frame. We already saw that when only one datum is repeated in the lower segment, the part is allowed to rotate within 0.1. In this example, datum feature B is also repeated, and this datum constrains the rotation of the part, allowing only translation. Here, this datum B not allowed to rotate the part about it. Now, let us discuss about two single segment positional tolerancing zone frame. We have taken in this given example at the lower segment a repetition of primary datum and secondary datum features. This similarity will help us better understanding of comparison to composite positional tolerance zone frame we already discussed previously. This animation explains that how two single segment tolerance zone frame works when two datum features are repeated in lower segment. As we know, in two single segment tolerance zone frame, each segment can be evaluated independently. With respect to per segment, the part can be translated and rotated within diametrical tolerance zone of 0.1. And with respect to lower segment, the part can be translated and rotated within diametrical tolerance zone of 0.05 relative to their datums A and datum B. The clarification doesn't end here. We know there is a rule stated that part must satisfy both the tolerance zone with respect to their relative datums given in upper and lower segment. And therefore, we can see that the part is translated within 0.1 in x direction relative to datum C, but it only allowed to translate in y direction within 0.05 relative to datum B. Thus, the part is well within both the tolerance zone given in the upper and the lower segment of two single datum feature frame. Here, a direct comparison shown between two single segment tolerance zone frame and composite tolerance zone frame. From two single segment positional tolerance zone frame, we can draw the conclusions as for the given example, the part which is a pattern of two whole features translated within 0.1 diametrical tolerance zone relative to the datum C in the direction of x, and the part which is the pattern of two whole features can be translated within 0.05 relative to the datum B in the direction of y. From the composite positional tolerance zone frame, we can conclude that the upper segment locates the part within 0.1 relative to datum A, B and C. It means the part can be translated in the direction of x and y within a diametrical tolerance zone of 0.1. And the lower segment controls the features within 0.05 constraining in orientation relative to datum A and datum B within the tolerance zone of 0.1. In the given example of two single tolerance zone frame, the tolerance zone diametrical 0.05 can be translated only in the x direction as shown in the animation, which is relative to datum C, and it is within diametrical tolerance zone of 0.1. In case of composite positional tolerance zone, the tolerance zone of 0.05 can be translated in x as well as in y direction relative to datum B and datum C. It is within the tolerance zone of diametrical tolerance zone 0.1. Let us see the application of two single segment positional tolerance zone frame. Here, the application is demonstrated of mounting of two parallel LM guideways on a bed. Let us explain one by one. Look at this animation of two single segment tolerance zone. Here, LM guideways mounting bed holes can only allowed to translate within diametrical tolerance zone of 0.05 in y direction. If both of the LM guideways are installed with these two single segment positional tolerance zone, then horizontal straightness and center distance between guideways are maintained very well with more accuracy, and it allowed a smooth sliding of the carriage. In the second condition of composite positional tolerance zone frame, LM guideways mounting bed holes can translate within a diametric tolerance zone of 0.1. Therefore, center distance between two guideways got more tolerances and flexibility. It could be a challenge if more precision is expected. We can see here center distances are changing with two different controls. This is how the real application of two single segment tolerance zone frame and composite positional tolerance zone frame.
Hope that you have liked this video, with very easy and simple explanations. You can comment how do you see this initiative and suggest more on upcoming videos. Also, we are pleased to conduct training programs at your locations in factories. We offer ASME Germany, an international CMM certification course. Basic of GD&T. Advanced GD&T. Stack up tolerances. Surface finish. MSA and other quality tools. For further details, please contact us. And I'm sure you will encourage the initiative of training through YouTube, by subscribing a channel. Accurate, ASME, ISO. Thank you and have a good day.
सर, मैं लोहिया चौबेपुर में क्वालिटी कंट्रोल पे काम करता हूँ और अभी मुझे GD&T की ट्रेनिंग दिलाई गई है, जो मेरे लिए बहुत बेनिफिट्स, मेरे लिए नहीं मेरी टीम के लिए भी बहुत बेनिफिट्स रही, जिसमें मेरे बहुत सारे डाउट्स दूर हुए और ट्रेनिंग के दौरान कभी भी बोरिंग नहीं लगा, एकदम इंजॉयफुल रहा और बहुत सारे हमारे डाउट्स दूर हुए और जिससे हमारी आने वाली प्रॉब्लम्स जो आ रही थी उनमें भी हम सॉल्व करेंगे। आगे आने वाली जो भी दिक्कतें थी क्वालिटी में, उनको भी हम पूरी तरह सॉल्व करेंगे।